Today we will be starting Chapter 7. In all of Chapter 7, we are going to be looking at what are called systems of equations. In this first section, we're going to be focusing on solving systems by graphing. So a system of linear equations is when you take two equations. So here you have two linear equations. They are both written in slope-intercept form, so that should be something you remember from Chapter 6, and you pair them together. So these two equations paired together are your system. When we graph a system of equations, we graph them both on the same coordinate plane. So you have two lines over here, both graphed on the same coordinate plane. So this is the graph of your system. A solution to a system of equations is an ordered pair that makes all of the equations in the system true. So for a system of linear equations, that would be an ordered pair that works when it's plugged into both of the equations, or in other words, a point that is on both of your lines. So if we look at these two examples, they are each already graphed for you, and we are just looking to find the solution to the system. So when you're looking at the graph, the point that's shared by both of the lines is going to be the point of intersection. So that would be this point here. So when we write down the solution then, we're going to be writing an ordered pair because that's how we represent a point. So for this ordered pair here, which is the point of intersection, we have to figure out what would be the coordinate. So remember, that's going to be an x comma y that would represent that red point. So it looks like we move from the origin, we're going to move over 8, and then we're going to move down 2. So that means that your solution to your system, or your point of intersection, is 8, comma, negative 2. If we move over here to this system on the right, which again is already graphed for you, we can see that the point of intersection occurs here. So to get to that point of intersection, again, we're going to move from the origin, and it looks like we're going to move left 2, and then we're going to move up 1, 2, 3, 4, 5, 6 units. So that means that the solution, or the point of intersection there, would be negative 2, comma, 6. So it's going to be really important that you remember that the solution to a system is the point of intersection. So when you write down these solutions, you are going to be writing ordered pairs. So if we are going to solve this system by graphing, we're going to graph both of these lines on the same coordinate plane. So notice that both of these are already in slope-intercept form for you. I'm going to graph them in different colors here to try to help you. Also, I would suggest that you have a ruler available as you're graphing because it is going to be really important that your lines are very straight. So I'm going to graph this first equation here in red. So it has a y-intercept of negative 3. So that means I'm going to have a point here on the y-axis at negative 3. And then from there, I have a slope of 2 over 1. So I'm going to go up 2 and right 1. And there's another point on the graph. Now I'm going to put a few more points on here because it's going to be hard for me to make a straight line if I don't have a few more points. But if you have your ruler at home, then you should not need extra points. You should be able to connect those 2 points. So this would be our first line. So then I'm going to graph the second equation on here in blue. Again, it's in slope-intercept form with a y-intercept of negative 1. So I'm going to cross the y-axis right there. And then remember, slope is the coefficient on x, which would technically be positive 1, which if I write it as a fraction is 1 over 1. So from my y-intercept, I'm going to go up 1 and over 1. So again, if you have a ruler at home, that's going to be enough for you to connect and create your line. And if you don't, then You may have to make a few extra points like I did, but then we can graph our blue line. So we can see that the point of intersection is occurring right here at that yellow dot. And so we need to write the ordered pair to write the solution, the ordered pair of that point of intersection. So that point, if I start at the origin, I would go right 2 and then up 1, which means that my solution is 2, 1. That is the solution to the system. Here's our next example. Again, we're going to be graphing a solution or graphing a system of equations and looking for the solution. Both of these equations were again given to us in slope-intercept form. So if I graph this first equation in red, it has a y-intercept of positive 2, and then we have a slope of negative 1/2, which means we're going to go down 1 and right 2. So if you have your ruler, then you can make a straight line to connect those points. I'm going to, again, make a few more points to make sure that I get this line in the right place. So there's our first line graphed. I'm going to graph the second equation in blue. So that one has a y-intercept of negative 3. And then my slope here would technically be negative 3 over 1. So from this point, we're going to go down 3 and right 1. So you can use your ruler to connect those points. So it looks like this is our second line. So we can see again that these two lines are intersecting, and here is their point of intersection. So our solution to the system is that point of intersection. So that point, again, from the origin, I'm moving left 2 and then up 1, 2, 3, which means that the point of intersection would be negative 2, 3. That is your solution. So here's our next example. Again, I'm trying to find the solution by graphing. So I'm going to graph this first equation in red. Now remember that when you don't see a value being added on to the end in slope-intercept form, it's supposed to be y equals mx plus b. It looks like we don't have our plus b, but technically we do. It's just plus 0. So that means that we have a y-intercept occurring at the origin. And then my slope would be negative 4 over 1. So that means I'm going to go down 4 and right 1. So these points will allow me to create the graph of that line. And then I need to also graph the second equation. I'm going to graph this one in blue. That one has a y-intercept at positive 5. So it crosses the y-axis here. And then its slope, the coefficient on x, is technically positive 1, which would be 1 over 1. So from that point, I'm going to go up 1 and right 1, which allows me to make this line. So I can see that we are experiencing our point of intersection right here. So that means my solution would be the point that's represented there. So from the origin, I'm going left 1 and then up 1, 2, 3, 4. So that point would be negative 1, 4. So our final example is here now. So for this one, you're definitely going to have to recall from chapter 6. So our first equation, which I'm going to graph in red, is y equals 5. If you remember, any equation that was written like this that only had y in it was a horizontal line. So this is going to be a horizontal line that crosses the y-axis at positive 5. So this is that line. And then for our second equation, we have x equals negative 3. So again, if you think back to chapter 6, any equation that had only x in it was a vertical line. And vertical lines are going to cross the x-axis. So it crosses the x-axis at negative 3. So this is that line. Again, I can see that those two lines do intersect. That point of intersection is happening there. So to describe that point, I'm going left 3 and then up 5, which means that the point of intersection would be negative 3, 5.